is to be able to kind of carry, like a briefcase, your Android reverse engineering environment and share that with others so that they can focus on really just the sample. So this is what I've done. I've done a Docker container, and I'll explain after why I chose Docker. The nice thing about it is that to install it is as simple as running docker pool and the name of my container. Okay. Well, it's not exactly a briefcase, it's more a suitcase, okay? Because depending on what you have on your laptop, for instance, it will be either a few megabytes to download or up to 3 gigabytes in the worst cases. So, could be worse. It could have been like that, right? Could have been a huge elephant, and this is precisely the reason why I'm not using virtual machines. I could have been using VirtualBox or VMware. Those are fine in plenty of situations, but here when I just want to share reverse engineering environment, well, the virtual machines, they are creating another operating system on top of your operating system. So it's heavier, you have more things to download, and also you have performances which are not as good as that. So that was one reason for the choice. Another reason for that, for using Docker, is that, well, Docker containers, basically you kind of script them to say what you want to put in the container, if you want this or that tool. And so it's basically just a big script, which is called a Docker file. And in that Docker file, well, you choose to put this or that. So in my Docker container, well, you can download it. Of course, that's on GitHub. If you decide, for instance, well, there is the emulator for Android 5 and 7. If you decide you want to work with 6, you remove 2 lines and you insert yours, right? It's not very complicated. And I'll show you a little bit what it looks like. So, yeah. So I have here the Docker container, which is already running. And then to connect to it, it's just like connecting to another host. In my case, I will connect using SSH. And my SSH for that container is running on port 5022. You can customize that, and you can put it to any port that you like, even the regular 22 if you would like to. 101. You can customize, of course, as well the password. And then there we are. Is that big enough? I can make it a little bit bigger. That's better. And, well, you have all the kind of plenty of tools for Android reverse engineering which are there. I have a few samples in this directory. So, for instance, I have here an Android ZTorg sample. We can run apktool on that. apktool, apk, ZTorg. Yep, it's because I've got to use that. D and ZTorg. And there it goes, like disassembling the sample. And you have the results in the ZTorg directory. You can have a look, for instance, at the Android manifest. You see that it has been converted to the text format. You can have a look at smali files if you'd like. Let's say, what do we have here? This class. We'll see that one a little bit afterwards. Okay, so, well, standard stuff like. What else can we do? We can launch an emulator. So there it starts, and I've lost the pointer. There it is. We also have Radar. I can launch that. This is the Dalvik executable for ZTorg. And while the emulator is loading. So my laptop is kind of a little bit old, so it should be running faster on yours, actually. And will I do this? And so here we've got the Android emulator. That takes, as you know, quite a lot of time to boot. And I'll go back to the slides. In the paper, you've got plenty of details as to how the Docker file was created. As it's only a 30-minute session, I'll skip a little bit that, but you have all the details there because it was a little bit kind of complicated. There are a few tricks, like when you want to start 2 daemons, you can write 2 commands. But if you do in a Docker file, well, the second one supersedes the first one. So you're not actually launching both daemons, but only one. So you've got to do a little trick to get both running at the same time if you want to. JEB scripting. So if you've been working on Android malware analysis, I guess you already know JEB. JEB is quite good tool, a disassembler and decompiler tool for Android. And like most disassemblers, it supports scripts and plugins to kind of automate some reverse engineering tasks. I thought while I was having a look at the documentation on the web, that it was kind of a little bit difficult to understand exactly how to write your own scripts. So now what I'm going to show you is like nearly a workshop. I'm going to show you exactly how to write one script in a case study for Android Z-Torg. So Android Z-Torg, it's a very interesting malware. The family appeared in 2015, but it's still active nowadays. And there's tons of features like anti-emulator, anti-debugger. We blogged about it. You can check if you want. It's not really the point of this talk today. Here, we're going to focus only on deobfuscating strings and do that with a plugin. So basically, it's simple. You have strings like that. Okay, that's not readable. And we want to turn it into something like that, which is far nicer, right? First thing to do, well, not reinvent the wheel. You've got plenty of scripts which are shipped with JEB, and they are in the scripts directory. So I suggest that you pick up in that directory something that looks like which is close to what you want to do. In our case, there was another script which was called JEB decrypt strings, which was decrypting strings for the OBAD malware, Android OBAD. So Android OBAD and Android Z-Torg are totally different, but still it's about decrypting strings, so there is a similarity. It's a Python script, and we can keep most of the beginning. The beginning, for instance, well, we want to open our Android sample. In JEB, this is called a project, right? So we're opening our project. Then the other thing that we want to do in the script is that we want to take all the decompiled source codes that we have and parse those, and we are going to deobfuscate the strings in those. In JEB, this is called a code unit, and so we have to look for Java source code unit, which are like that. Then, of course, you've got some lines in that script which are specific to Android OBAD, so we can remove those. And what we have to do is get like a handle on our decompiled class. So this is represented by the object which is there, Java class, which is of the type iJava class. If you go and see the API on the web, it will tell you that there are plenty of methods for that. That will tell you in your decompiled class what are the methods, what are the fields, what's the name, plenty of interesting stuff. In our case, for Android Z-Torg, it happens that all obfuscated strings are located in the static constructors, in the class constructor, right? So what we want to do in our script is that we are going for our Decompile class to list all methods. Oh, this is method A. I don't care. Method B, I don't care. Oh, this is the static constructor. I want to go into that and to do some more processing there. So this is what we're doing, getting all methods, and filtering just static constructor. So we're in the constructor. The constructor is made of lines. Well, more precisely, those are called statements, right? And we are particularly, we have to have a look at lines which look like those, like a value equals, well, this is our decoding method and the obfuscated string. So precisely, we're looking for assignments. So that's what we do. We filter out and we only keep lines which are assignments. Then more precisely, up there, have a look on the right-hand side. Well, we want something that is first calling a method, and that method must be c.a in our case. Well, I'm sorry about the names, but they obfuscated all the names as well. So that's what we have to look for, and that's what we're doing in the script. We get the right-hand part of the statement, check it as a call, and check that the method we are calling has the right signature. Okay, so we are in an interesting line, and we need to deobfuscate the string. Where is the string? The string, the obfuscated string, it is here as an argument to that decoding method. So, well, we get the arguments, and we check that it's a new byte array. We're going to put that in a temporary buffer in our Python script, and we deobfuscate. So how did I write that method there? Well, by doing some reverse engineering in the sample itself, found how they were working out, how they were deobfuscating the strings, worked out that it was like 2 different XORs with 2 different keys, and writes the method in Python. So we have the deobfuscated string. Okay, we have it, but that's good. But now we've got to display it. So we are going to modify the line in the user interface and modify and change the obfuscated string by the deobfuscated one. So we do that with in JEB with replace sub element. You can check the API after for that one. Final thing we have to do is to tell the user interface, okay, I've modified something, please redisplay. And that's what this command is doing, notify listeners and telling it to redisplay. And that's it. It's done. Okay? I'm sure you want to have a look. Well, the code is shared as well on GitHub if you want to see it with your eyes. And I'm going to show the video. Okay, so let me perhaps make it a little bit bigger. You see that we have here all the obfuscated strings and the call to c.a, which is our decoding method. We are going to call our script, as simple as that. It loads, and there it goes. Oops, I'm trying to. We have the results all deobfuscated. Okay? There we go. Debugging. Debugging is something else which is nice to have, right? I guess that on all kind of advanced samples, one day or another, you bumped into something where you would have wished that you could, step into the program, see in which branch it was going, see the values for the variables and things like that. To my understanding, my knowledge, there's only two tools for that, JEB again, and code inspect. Right? When I wrote the paper, and so this is what you will have in the proceedings, that was in March, and at that time, well, both of them were really not behaving correctly. On the paper, it should have been great. In practice, it was crashing all the time, and it wasn't usable. I've tested again like 2 weeks ago, and it really improved. I was surprised. Now code inspect is in a really usable status, for example. So I'm going to show you. I used code inspect over a riskware, and I had that problem. That riskware, I had done quite a lot of static analysis on it, and it was loading a Dalvik executable. And I was having difficulties to understand what was the file name of that text that it was loading. So I thought, okay, I'm going to put a breakpoint on the file name and see what's the value. So that's another video. There it goes. So it's already loaded in code inspect. That's that riskware in a snail. And I'm going to locate exactly, go to the place where that Dalvik executable is being loaded. So I'm going to make this a little bit bigger. Where the Dalvik executable is being loaded, that is through the class dex class loader. And in particular, when we create an object of dex class loader, the first argument in that class is actually the file name of the dex we are loading, right? So I'm going to find all references for that first argument and see at what point exactly I want to put my breakpoint and inspect the value. I set the breakpoint, and now I'm going to launch the emulator. Start debugging. It attaches to the process and loads it. A few seconds later, you will get kind of the result. It is waiting for the debugger and will switch to another view. And now we are exactly in the code at that breakpoint I had set. Sorry. And this is the value before it has actually been assigned the precise value I am looking for. So we only have the path at that point. I step over the instruction, and now, well, we have the full path of the RDEX. Look, it's there, okay? It's named .zip at the end, but it's a Dalvik executable, actually. So that's one way to do it. That's a backup slide-in case. Another point, man in the middle. So what happens is that we have more and more Android applications which are using HTTPS. That's the good news. It means that people are more and more security aware. The bad news for us malware analysts is that, of course, we get for malwares more and more encrypted data flow, and we'd like to inspect that. Not going to learn you anything. What we're going to do in that situation is we're going to do a man-in-the-middle attack. The good news, though, is that we've got a tool which is already ready for that, which is called man-in-the-middle proxy, and it supports Android. That's good. So what we do, we put our laptop there in the same network as the phone, and we are going to send it over our certificate authority, and then we say to our phone, we're going to change the proxy settings and tell it to redirect all our network flow to the laptop. On the laptop, we have man-in-the-middle proxy, and we can see and view everything. all the flow. So you can intercept it, you can read what is being sent over, you can even modify it if you were interested into modifying what is being sent over. That's as well possible. So that works pretty well. Radar. I told you I'd be talking about radar again. So radar, I don't know how many of you are used to using that tool. It's a command line disassembler, kind of old style or geek style. It is pretty much used by people who are doing reverse engineering on embedded systems, for instance, because it supports loads of architectures. And one of the architectures that it supports now is Dalvik. So that is interesting in our case. So I'm going to show you, but actually we can do some pretty advanced stuff with radar. And I'm going to do a string deobfuscation with radar on the same sample, ztorg again. So, yeah. We are here. I have loaded, as I told you last time, the Dalvik executable of Android ztorg. I am going to look for a class named ADD. So AFL, which is here, means list me all functions, and then I'm kind of grepping through to find only ADD. And now I am going to disassemble, like for instance 80 lines at that location. So there we go, we copy, paste. Okay, so we've got the disassembly. Radar is the kind of tool where it's nice to have a big screen, right? So I'll go with the beginning. At the beginning, what do we see? We see here, this is our class ADD, and CL init, which means that we're in a static constructor for that class. And then you'll recognize a few stuff. Here, we are creating a byte array. Here, we are filling it with some data. And then, look what method we are calling. We are calling, again, our c.a. So that is our decoding method, right? So this is exactly one case I have shown where we are going to deobfuscate the strings. And so the data for inside the array, well, they're here at the end. Those are all like the obfuscated strings. So for instance, let's have a look at, I don't know, this one. And which tells us that here we have a fill array data payload with 41 bytes, right? So I'm going to show you the obfuscated string. And it is located just after, so at this address and after this bunch of bytes, which are the opcode for fill array data payload. So px, we are going to show 41 bytes at this address plus 8. And this is the obfuscated string. Now we are going to deobfuscate it, and that's cool. We can launch some external scripts with radar, same thing as JEBA. And I wrote a script for that one. ztorg, you have to provide the address of the obfuscated string, copy, paste, and we have 41 bytes. And there we go, we've got the result. So that obfuscated string, oops, well, you have it here. Okay, turns into a URL where the malware actually contacts stuff. And Well, I have the script you can have a look at shortly, which is there. So it's a Python script. And I'll explain a little bit better with the slides. So to write a radar script, what do you have to do? Actually, it's pretty simple. You have to import the R2 pipe package, then you connect to that, and then you just have to tell to that connection all the commands you'd like to submit to radar. So yes, so the commands to radar are a little bit like funky and difficult to grasp at first if you're not used to radar, but if you are used to radar, it's really pretty easy to script. And that's how we do the stuff there. Right. And I think that's about all. Just before we get to the questions, perhaps, we'll just say that we are organizing a smart devices CTF capture the flag on the French Riviera. It's on the end of November, and that will also include actually some challenges on Android smartphones. So if you are interested, you are most than welcome to come, and I'll be happy to welcome you.